Hey, everybody, welcome back to the Provider Podcast. This is your host, Koby Pierce, and your co host. I run an IaaS service provider called Hybrid Hosting, and Leifur.
I'm a recent startup founder for the seventh time and still a salesman at Path Networks, a DDoS mitigation company.
Yep, just a quick reminder of the goals of this podcast. Our goal is to demystify complex terms related to cloud, AI, infrastructure as a service, the internet, and avoid technical jargon and just describe it to you in the best way possible. So in this episode, we're going to be going over AI. This is our second episode in total, but our first one about AI in our AI series. I can guarantee you we're going to be having multiple of these.
Oh, yeah.
Yeah, this is a big topic that a lot of people probably want to know about.
Yeah. So I'm going to let you be the driver here, take the back seat, because this is where you've been dipping your fingers in lately and have for a while. LLMs, AI, everything. But I'll be interactive, and I know some of it. I'm more on the data center side, more in the provisioning side for the AI operators rather than knowing everything about inference and compute. But I can still provide some good value to the listener. Let's just dive right in. What is AI? What does it stand for, Kobe?
Artificial intelligence can mean about 100 different things. At a ground level, AI can be anything from a simple predictor of where you're going to tap on the screen and how fast you're tapping to load pages correctly, all the way up to something like ChatGPT or full self-driving in a Tesla for robotaxi. There are a few different types that people need to understand. The first would be your actual artificial intelligence, which I like to use the term artificial intelligence when you're discussing deep learning. Uh, Convolutional neural networks, which we'll get into, power things like ChatGPT or like self-driving car models. But some of the stuff like day-to-day, like your just random algorithms that are super simple, if-then statements. People still like to call them AI, artificial intelligence. I think there should probably be a new term for it, but that is also an area where AI is used. Whenever you get to the point of deep learning, all deep learning is having a computer make those if-then statements for you.
Right now, we're in this period. The venture capitalists would call it a bull run about AI. Everything is AI. Y Combinator is, I think, 80% AI companies are GPT wrappers this year. And that's not the AI I've known for the 10 years I've understood it. But these are what LLMs, large language models. Why is this breaking out now with GPT 3.5 and up to today? Where's this coming from? And is this AI? How do you understand it? How would you explain it to a listener who thinks it's a dubious marketing trick?
Yes.
You know,
Right now, the whole AI trend stems from just ChatGPT. It's the first time that a company has taken AI, made it consumer facing, and then throw it in a back and forth like a chatbot. There have been with GPTs, just the transformer algorithm, which is a type of AI that is mainly used in generating text. It has been around for 10, 15 years. I remember 6 or 7 years back playing with an AI text generator. They can predict the next word relatively well, but they are not capable of responding to a human.
trying GPT 3.5 in their, I think it was an invite only beta. My friend told me about it, and he was telling me, you're becoming a lawyer. Look at this here. You're not going to write a contract in your life. I ignored him. No way. This is
Yeah.
2021 before GPT 3.5 comes out, which is based on the same model. But I go try GPT 3.5, tell it to write a contract. It does it fantastically. Absolutely. Just every article is standard. It's because the database is so large. And
Yeah.
it's even larger today.
Yeah. So I remember back in the day, it used to be basically a meme.
Yeah.
It was, but before even, I think this was 2016, if I remember. I don't even remember the name of the program. It was some open source thing. I downloaded it off GitHub. It was running on my 1060 GB from NVIDIA. I pasted in half of a movie script and had it finish it. It did get into a loop, but it started to make intelligible sentences. I knew it was going to be something. Eventually, I think
Yeah.
most people that tried it knew finally, was it 2020 or 2021 when ChatGPT released?
2022. Yeah, it's
Oh,
not
was it?
that
Oh,
long ago, but I mean,
that feels weird.
what is it? So I think a general understanding of what's going on there, it's a computer. It's not a person writing that. It's not some call center writing on the spot for you, as some people believed. So what is going on? Where does this intelligent, where does that come in with the artificial? What is that intelligent?
In my opinion, is not something to be worried about. A lot of people are scared that it is doing reasoning and logic.
Yeah.
It is not. That is just
Mhm.
plain of the fact not true.
My understanding
It,
is it's just predicting the next word based on the database that it has and giving values for each word. It's an LLM. Or if you could go further into that.
I'll explain. So basically, a large language model, its fundamental is a bunch of what are called parameters. You can think of them as neurons in a brain, but
Mhm.
there are thousands of, and they can be in what's called different layers. If you've ever looked up a picture of a convolutional neural network or a CNN or an AI, you see all of the dots that connect together. Those dots are what we call parameters. That's just a way of visualizing AI. It works in that way though. Between each parameter, there are those lines, which some people like to draw them as weighted biases. So the biases are the parameters themselves, and the weights are the actual lines between them. This is just a loose telling of how they work. They multiply a number that is given as an input. In the case of large language models, billions to trillions of parameters all multiply numbers together to create an output, which in the case of ChatGPT 3 or 4 come out as text. The thing is, though, the AI actually doesn't understand human speech or human
No.
text. It is fundamentally numbers. It looks at its training data. When you're talking to ChatGPT, it is not actually seeing the text. It is running on something called tokens, which in a transformer model basically take your string of text. So your sentence, "Hello, my name is Koby." Parts of that sentence, normally 3 to 5 characters, are taken and identified as a number. For example, hello can be its own token. Part of hello can be a token. So HEL could be a token.
Tokens good.
What basically how that works is all of those tokens are taken together, and those are actually the inputs of the model. And it uses those weights and biases to multiply, subtract, like all of the math, and
Yeah.
it comes out
I
in text.
understand ChatGPT and or GPT 4.0 and Meta Llama, Facebook's side, still have different databases, but they may also have different ways of calculating, I assume. Different
They're
calculations,
also,
different formulas, but
yeah, they're not
trying
databases. So how the actual AI models themselves work is they don't have access to their training data when they're running on inference, which means whenever
yeah,
you're
yeah,
communicating with them,
right.
their parameters and weights and biases are trained based on that. They throw those data sets at the AI however many times, which is what they call epochs. So if you throw it at it 3 times, that would be 3 epochs. That means you go over the training data set 3 times.
Yeah.
And basically, what you're doing is you can think of these thousands of little knobs, like an old car radio, and think of a robot going through and twisting each one of those parameters randomly and seeing if there's a better or worse outcome based on your evaluation data, which is
Right.
saying the output is this good. Now we've actually started taking models like ChatGPT have gotten so good that they are their own evaluation. So you give a question and they evaluate the answers for those models, which is really quite interesting because the reasoning behind them changes. Um, so we've gotten to the point where I think that evaluation doesn't even do much anymore. But what you also have to think of is ChatGPT is not the only. We should talk about some other more important AIs because ChatGPT is super important and super helpful. Most people know that it is like a lifesaver and just improves my efficiency day to day by a
Yeah,
huge percentage. Um, it doesn't do my job for me.
exactly.
And but once it's doing my job for me, I'll take that back. But another AI that I find super, I think came before ChatGPT and still to this day is more intelligent at times is the YouTube algorithm, which is an artificial intelligence convolutional neural network. What that does is the same type of AI, right? There's thousands of parameters. And the inputs to the AI are basically what videos are available to send to the user, how long the user's already been there, the previously watched videos of that user.
Yeah.
And then the outputs are how long the user was there. The AI model's goal is based on how long it can keep you on a platform. So the better it serves you those videos, which is the same thing with the TikTok algorithm, the YouTube Shorts algorithm, the Instagram Reels algorithm, and the same thing with all of these platforms. Underneath the hood, they're all
He's trying to get you the best videos each and every time.
right. They're all different databases, as you were saying, or data sets. There is showing that there's new models that can actually adapt to each person, which will be super interesting. When we have smaller models, they're fine tuned on the big models, individualized for each
Is that
person, which could
what the 4.0 mini is?
no. So the 4.0 mini and the 4.0 in particular, I'm not really big on the huge ChatGPT naming scheme.
Editor's note here as we are taking about 4.0, we are really talking about the 0.1 and 0.1 preview models.
I think kind of strange, but those are a really cool way of doing ChatGPT. It does create more intelligible responses from experience, but it is not actually reasoning like they want you to think. There are multiple different ChatGPTs.
That's right.
So when you actually type something in, you'll see it'll say thinking ...
Yeah.
Yes, it's two. From what I can see, it's two AIs. One AI basically figuring out it sees the user's query and provides questions on how a human would think through this. It goes step by step. That model talks to the other thought model, which actually does the thinking. It says the quote unquote thinking. It's trying to pretend like it's thinking. So it's going a little deeper. Think about this. It writes up a paragraph to itself about a thought. It's like that inner dialogue in your head. It's trying to become that. When you finally get a response, that is another AI, the main AI, taking the thought process from the other AI as it takes the human query and the thought model's answer into account, resulting in a better model. They'll call that a train of thought reasoning model, which can improve performance a lot.
Let's get back into the video recommendation models. You were talking about that, and they've been here for a while. YouTube is 2005. Have they been doing the same kind of recommendations ever since?
There used to be some more classic if-then statements, and then
Okay.
you come back with convolutional neural networks, but that was pretty early. I think that was like 2 or 3 years into YouTube. You can correct me if I'm wrong.
Yeah, that's the first kind of AI I knew about as a kid. Is okay, yeah, YouTube, that's an AI. What is this AI?
I think it's 2010 is when they started.
Yeah,
could be
that
wrong.
checks
Is that-
out.
if anybody-
No, that does check out. When YouTube exploded, 2010 to
Yeah.
2015 was huge, and that's just running these models, right? That is trained on your data, or that you're having an effect on. You neglecting a video, or watching it, or liking it, or disliking it has an effect on the algorithm.
Yeah. The one person may not be able to make a difference to the model, right? You can go through and skip through a bunch of videos. The AI has so much input on you and other people. When it sees that you're clicking through a bunch of videos, trying to get it to recommend one thing. For example, you want your algorithm to start showing you videos about data centers. You search up data centers and start clicking on a bunch of only watching 2 seconds. It sees that pattern and determines you want more data center videos, but not these ones. Because other people have done that and shown them high quality data center videos.
So,
like these people,
Dear
like this.
listeners, next time you want something recommended, just watch one video for a while.
Yeah. So as you're listening to this video, Spotify is now going to start recommending to you the data center podcast.
Everything.
Yeah.
We're going to do AI podcasts. There must be really nitty-gritty podcasts that go into very intricate AI topics that I could not get myself on. But here, well, I'm just trying to go into the basics.
So
Maybe you'd get recommended The Big Think by Reuters. That's a good podcast. But Spotify has an algorithm like that.
I do want to go through Spotify's like listening algorithm. Apple Podcasts does not have one. It's quite bad.
You want to get into?
So I wanted to get into there are multiple types of AI. What we've seen now is transformers and convolutional neural networks.
What that is quickly.
Transformers is a way of doing AI. It's an architecture of deep learning. It was developed by researchers at Google. There's a few ways of doing it. One way is a way that I like to explain to people how AI works is tuning models. Think of it like a car radio knob, adjusting it until you get the right output. There's also something called a genetic breeding model. You take multiple convolutional neural networks. A lot of the time, they're if-then statements with parameters. And those start off with random values. So each parameter is a random value between -1 and 1, right? And you start off that way. And basically, you have 1,000 AIs that are all randomized. And they don't start off as AI, they start off as not intelligent, artificial dumbness.
I think somebody tried coining that. You wanted to get into these different AIs, so
Yeah,
we could just
so
lay everything out. What are differing AIs and where can they have an effect on people? Where are they seen? Can you see the different? Can you spot the difference from a user perspective, and or some only use in business environments where they have no effect on you?
nowadays, convolutional neural networks have taken transformer-like models. Not everybody uses transformers, but most people do. Some image generating models don't use transformers, but
Okay,
there's
convolutional neural networks. What does that mean? Like, what's behind that? Yeah, I know you said it's like neurons zapping around in your brain.
so basically filter optimization. You have filters and gradients. I won't get into all that. And you have your back propagation. You want to really think about those parameters and how it takes from the convolutional neural network. For example, let's talk about images. You take an image and you break it apart into 10,024 pixels, which is a really low quality picture. And let's turn it grayscale as well.
Okay.
It's basically a bunch of filters to make it easier for the neural network.
Right. Let's compute.
One thing I like to talk about is that the same type of like neural networks power everything. Neural networks, from the base topic, when we're talking about YouTube, we're talking about Spotify, we're talking about Tesla's full self-driving to ChatGPT. Those are all based on neural networks. And that's really what comes down to AI. So when you think of AI nowadays, most people think of a neural network.
Right.
We also have to talk about non-neural network AIs. Let's take my favorite example, which is Waymo and Tesla. So Tesla is all neural network now. They used to have some human code on highways, which is basically the human coded version of AI, which is not neural networks, doing lane detection. That involves turning an image into a grayscale, finding edges, and then drawing a line. It's more high complex coding, not necessarily AI. Like the neural network side. It's an if-then statement. If the lane is going left, you also turn left. That is what Tesla used to use on their highways. Now they're
neural networks,
complete
yeah.
end-to-end.
We're talking about their full self-driving, right?
Right. So
Yeah.
now with their new V13 full self-driving, it is from the time that you're sitting in your driveway, you click a start button, and it'll get you to a destination.
Do you use it a lot?
Myself, so there's in Teslas, there are two different models, newer models and older models. The newer models have something called hardware 4, and the older models have something called hardware 3. That is what's called an inference computer or a TPU. I don't think Tesla necessarily calls them TPUs, but they basically are a low powered unit to specifically run AI models.
There's an AI computer in the Tesla, right?
The hardware 3 was released in 2019. They installed it on all of their previous cars as well, even the 2018s and 2017s. They went through and did a retrofit. But that was designed when they didn't even know they wanted to do neural networks.
Okay.
That was designed when they were still doing the human code. It was not future-proofed for what they were doing. Now they've switched to neural networks, and hardware 4 was designed specifically for neural networks. It's a lot better at running AI models, and there's a lot of room.
Then I'd say there's a trend going away from the old guard into neural networks. Most definitely.
Yes. The issue when I was talking about, I use it and I think it's great. I don't like to use it a lot. This is a huge example of something that I like to talk about. I'm actually working on a research paper about AI distillation and pruning. Basically, you're taking a big AI model and making it smaller to run on smaller hardware. The reason we would do this is in the hardware 3 versus hardware 4 Tesla debate. A certain AI model running on hardware 4, which is a super powerful thing. There's 8 gigabytes of RAM, on hardware 3 and I think 16 on hardware 4. Hardware 4 also has, I think, 256 gigs of storage on it. So it can store up to a model that is 256 gigabytes in size versus hardware 3, which, if I remember correctly, is 32 gigs. The issue Tesla is running into now is their AI models are getting too big. Their neural networks are getting so large.
Right.
They can't fit the newest models on hardware 3.
It doesn't communicate with any outsiders or whatnot.
I think you want for your car running
That
on
can
a
be-
server where your cell tower goes off and now your car goes off a bridge.
Exactly. So it's
Yeah.
only local in the car.
You also need millisecond latency or less to be able to do that, and the bandwidth capabilities to be on board.
And Waymo, for those who don't know, that's a Silicon Valley and company that Google bought, which is doing self-driving. It's a shuttle service or the taxi service, right?
It's robotaxi service. It is actively running. It's really impressive what they've done, but they are using a different method to Tesla. Tesla is doing the all cameras approach, which means there are 12 cameras and the AI is getting the feed from all of those 12 cameras and making decisions based on that neural network.
Yeah, just on the spot, making decisions based on the numbers, given the values. I assume it sees a pedestrian cross over. Does it run that person over, or does it come to a stop? Does it slow down? How much does it need to slow down? Like, that decision is
So-
based off the camera feed, and it does that locally on the computer.
So how they do that is they take all of the data from all the Teslas, which I think they have 9 million Teslas now. They have all of the video feeds. Every time you get done driving, you connect back to the internet, you'll see in your router that they start uploading all of that video feed directly to Tesla. For some, it's scary, but they are very big on security. There are no identifiers to your vehicle or where you are, and it is just being run through an AI model. There are so many hours of video that there is zero possibility of a human going through and actually reviewing all your data because of the billions of hours of video. There's not a human saying, slow down and don't run into this person. They're actually taking the video from other drivers, and this AI model is running off of that. So it's looking at how human drivers drive and trying to replicate that.
Okay, so if we compare ChatGPT, instead of most likely word to come after that, or most likely token to come from that response.
It's actually the same thing. So it results in, for example, steering angle, right? Let's say your steering angle is between 360 degrees and negative 360 degrees, which is not realistic, but in the Cybertruck it would be because they have two-wheel steering. Where should the steering wheel be? There's also the accelerator and other inputs like gyroscope and the current speed of the vehicle, which are important. The main part of it to know its surroundings is based on images. Waymo uses cameras, but also a suite of LiDAR and radar. Wow. Each vehicle costs a lot more than Tesla's because Tesla's cameras have gotten really cheap. LiDAR is extremely expensive. The issue with Waymo's, their approach is way more human coded. They have sub neural networks because they have to, for their lane prediction and other things, they have a bunch of AI models combined by using human code, which is not as reliable as a full neural network. Waymo's out on the streets doing this stuff versus Tesla, but Tesla is building a more robust system. You can drop the car anywhere in the US or Canada right now. I'll go into something a little funny later. And it will get you from point A to point B anywhere in the US or Canada. In my experience watching other creators, my car with hardware 3 is not at that level. I have a friend that has hardware 4. His car can go from point A to point B without intervention.
Yeah.
My car can as well if it's lucky. The new models have shown to have basically zero interventions. A funny story was that a guy tricked his Tesla into thinking it's in the US and shipped it to Russia and did some hacky stuff on it. Oh, it did.
It did.
It's really funny. Is everything about Russia's driving is completely different. The video has been leaked and published online of it driving through Moscow and following traffic laws.
Yeah, and that's
in Russia. And they've
Russia,
never had a single ounce of training data from Russia, which shows
that's
how
just
robust
based
these
off.
models are.
Okay,
Yeah.
so during the time that it was there, it learned to drive the Russian way.
It didn't learn to drive Russian. It was staying in lanes and watching how other drivers were driving.
It was replicating that.
It saw that everybody was driving closer together and going a little bit to the left or right. They were all turning at this exact sign, and it was realizing that and repeating that. So he actually did a zero intervention drive from point A to point B using the Russian maps in a Tesla with full self-driving, which shows the redundancy and the robustness. Versus Waymo, if you did that, it would crash into a light pole, which is an
Okay.
actual thing that one of them did.
Now we got a bit into that was a great discussion on Tesla and Waymo. I think those are good examples of how AI is having an effect on daily lives as well as ChatGPT, because a lot of our listeners are either hardware investors or
Yeah.
investors in digital infrastructure, C-level execs, middle management in data center companies, whatnot. Maybe it's
Right.
good that the people that are selling the stuff know what it is, and the general public as well, our listeners. I wanted to get into the difference between inference and compute, and what's going on with the companies Grok with a Q and NVIDIA, the hardware. We'll do an episode on it later completely, but just to show why is NVIDIA blossoming right now? What's going on?
Inference is the process of actually running the AI model for the user. For example, Chat is probably in a data center, maybe Azure. Inference for a Tesla is on the hardware itself in the car. Apple is trying to do their image generation, which is also being inferenced off the phone. Inference is when you're running the AI model for the user. Compute is what most C-level execs and data center managers stress about, which is when you're actually training those models based on the data. That's why you hear about Elon's new XAI in Memphis building the world's largest data center. Those are
That is compute.
we're taking those massive data sets, throwing them through the models and getting an output. That output model is what we throw onto inference, which ends up running on your phone, your car, or another data center to throw text back at you on ChatGPT.
Okay. I want to get into these companies like NVIDIA. Why is XAI, Elon Musk, buying 100,000 H200s, H100s, Blackwell chips? And what are those? What's going on? Why can't you just use your computer that you have at home?
Right now, I think the Memphis Center and Cortex in Dallas, his data centers for Tesla, are training clusters for these models because that is the most compute intensive part of AI. Running the model is getting more difficult, but it's a lot easier to run an AI model than to train it. As we require more from our AI models, they need more training. The reason NVIDIA is doing so freaking well is they designed the designers of these demanded chips for these AI training compute. Because companies' main issue is power, which we can go into later. You talk about that, and you'll love that. They want their GPUs to be more efficient so they can train more AI models with the same amount of power because they're power limited. NVIDIA was designing these super efficient, super powerful compute to do it. What most people don't realize is NVIDIA doesn't actually create a single GPU. They send it to their manufacturer, TSMC, a Taiwanese company, to make these chips.
So what does NVIDIA do?
NVIDIA designs the chips. Then there are billions of dollars of research and development of these chips, which is crazy to think about. The amount of research and development goes into it is way more than the actual production.
Okay.
Production of these chips to be $10 to $20 a CPU because a wafer costs now like a few $1,000s and you can make a few hundred GPUs off of it. The dies are getting larger and that's a little bit different for the data center space. But the chip in your phone doesn't really cost all that much to make, but the research and development is the actual cost of it, of these chips, which is why NVIDIA is just making so much gosh darn money right now. They're the cash printing machine. And right now, NVIDIA is leading everybody. I've heard that Elon is going into the chip space and they're designing what they call Doge chips, which are cut on the H100, the Blackwell chips, the H200s, these training chips, so they can actually start deploying their own, which will be very interesting to see because Tesla, XAI, those companies are actually some of NVIDIA's biggest customers.
Yeah. Could you get into NVIDIA is better in compute than, say, Grok, GROQ. Have you heard of Grok?
So
That
I've heard a
company?
little bit about Grok. I've heard
Right.
more about this other company. They are making chips that are supposed to be hyper efficient just for training transformer models,
Okay.
which will be very interesting to see. NVIDIA makes x86 GPUs. x86 is an instruction set that runs on your computer. And there's only two main instruction sets that most people talk about, ARM and x86. x86 is most likely in your computer, while ARM is a lower power reduced instruction set, which is what's being run on your phone. So your phone doesn't overheat as much, and it's more efficient. But you do have to rewrite all of your programs based on that. And what these companies like Grok is doing with a Q is they are creating chips that are specifically created for training transformer models. And the reason that most of these big companies like Azure, AWS, and Tesla are buying NVIDIA's chips instead of these specially made chips is we
Yeah.
don't know where the future of AI is going. I think we're still in the very beginning of AI. We're in the internet 1.0 stage. This is the first version before we're really getting into some real useful stuff. And transformers may not be the future. For example, I don't think Tesla uses transformers for their full self-driving system. I think they use a custom in-house solution. So those transformer chips would just not work for Tesla, which is why I think NVIDIA is making so much money. They're making GPUs that can train any type of model. The reason x86 GPUs are so popular and not something like an Intel, right? I've been asked by a bunch of execs for a data center company, why aren't they using Intel? Why is Intel falling off? Why can't they use CPUs in training these models? The reason is parallel computing. A CPU may have 8 to 16
Yeah.
cores, which are individual tasks, versus a GPU, which can have tens of thousands of processing cores.
I've heard.
CUDA cores, yeah. So these CUDA cores are a lot less powerful, but they run in parallel. And what happens is when you're actually fine tuning these giant models, right? You're turning that knob on your radio. We have trillions of knobs. So we have to turn each one of these knobs just a little bit.
Yeah. Very good.
It's
An Intel CPU is only turning 16 knobs if it has 16 cores, but NVIDIA is turning 10,000.
and it's wasteful to run those super powerful cores for a singular little
Not. Yeah.
a singular knob. That's what we were calling it. Versus a GPU which have thousands.
So, is the future of AI for these companies what our listeners may be thinking about right now? Should they be investing in inference or should they be investing in compute? What are the opportunities?
Inference runs on generally the same architecture as your compute at the data center side. Once you run on the consumer side, there's what's called an NP, the neural processing unit in your phone. These are specifically designed for inference and being very power efficient, which is also what runs in the Tesla. At the time, inference is super important. The issue right now is the price. To run, reportedly, OpenAI is losing a lot of money even for their pro users,
Yeah. Okay.
just
Wow.
because of the pure cost of inference. Pilot is losing money
That's creepy.
because of the cost of inference. Now, this cost is going down, and that's another reason we're taking the AI models and doing this distillation, which is taking the very large model that has a lot of parameters and compressing it to a smaller model with the same amount of intelligence. Cheaper to run and more profitable.
Inference for Apple and everything, that's free. It's on your phone. They don't need the. Whereas with
Those
OpenAI,
models are also built that prune through your data set. They make the models super efficient. It's
whereas
really fascinating to me how they actually fit that to the phone. I need to do some serious research how they do that.
we could do an episode definitely.
Versus compute, which is where the real money is being made right now.
Yeah.
I don't know how sustainable this is going to be. At what point is it like GPU mining for Bitcoin? There's a chance it's like that, but also a chance we continue to need more and more. It could be that we find the limit of our current architectures of the AI. I don't think there is a limit on how intelligent AI can get. I think we will always be making AI better. It'll be slow. You're going to find more efficiencies. I don't think there's going to be any huge breakthroughs past the next 10 years. I think in the next 10 years, we'll discover most of the breakthroughs. I could be wrong. There will be breakthroughs in the future, but I don't think there will be as often as we're getting now.
You think it's going to slow down?
I think it will slow
Okay.
down. But in the next 10 years, I think we will start to see more models based off of the actual human brain. For example, one thought experiment that I've had for a while is, what if you strap 2 cameras to a baby's head around the eyes and some microphones in the ears, right? And
Give it a
react
sensing.
for all of its sensing abilities for touch and training an AI model on that, would it become
Yeah,
intelligent?
would the AI learn the human language like the baby would?
So the thing is, you're giving it the same input. It's interesting because the neurons in your head are timings. Those neurons are firing at a specific time. All we're doing is adjusting that time. That's how our brains work. And in AI neural networks, we're just adjusting the weights and biases. Is it possible that if we replicate the human brain in parameters and weights and biases, that we come out with said intelligence? That is where I don't know if that'll end up working. Can we get that to work? Is it the evolution from our thousands and millions of years of existence that have made those starting random parameters in our brains intelligent? And if so, can we measure them? I think that there will be a lot of use for compute in the next 10, 15, 20 years. Now, there's also, I think, a huge thing on inference. Inference will eventually be started to run on like more local data centers or local pops, right? You have Spectrum down the road, right? You have your.
There's going to be RAN there. You're going to have an AI in
I
your
think so,
in your neighborhood.
because
A lot of AIs in my neighborhood, or
we
not in my
need
neighborhood, but nearby. Nice.
we need lower latency for a lot of these things, right? Because if you've seen the new ChatGPT voice models where it's talking to you, you can see it actually takes a second for those milliseconds to go by to transfer that data. So I think the closer it is to the user, the faster it's going to be.
Or something.
And
Yeah.
it's been a pretty deep dive into AI
Pretty deep dive.
inference training. There's still so much more to go over. We could go over how AI models are trained, the GPUs, how they actually work, power requirements.
I think with the trending part of AI bubble, for me, it's the data centers. I want to get more into this hardware and why it's taking up your local power, nuclear SMRs that are being built. I think we should take that next time into this. Go deep on that. Explain, we'll go a bit into data centers. We'll go into this NVIDIA stuff. I'll do some more research. This is just a general discussion of AI with some quick deep dives. The first in our series on AI, and next time we'll do more deep dives into specific subjects, maybe one episode on data centers and hardware. We could take on a guest, making a model, somebody from Iceland, let them explain.
I'd like to say for all of the listeners still listening, this is our second episode. If you want to drop a like and comment, that would help extensively. Still trying to grow the podcast. We're sorry for the long time between episodes. It's schedules and everything, but I'll promise that we'll have more episodes coming out.
We have a couple things in the works. Interviews are coming with industry leaders and great, amazing people with amazing stories.
For y'all to understand how we're going to do this, we're going to have our main episodes, which will just be me and Leifur describing topics like this, the overview on AI, and we'll have podcasts, for example. The next podcast episode might be about AI at the data center. We'll have somebody with AI at the data center, and that'll be an interview about AI at the data center and learning a bit more about that from industry experts. So that's a wrap on episode 2 of the Provider Podcast. Anything else you want to say?
No, I just wish everybody happy holidays. I know Hanukkah's on the 25th and Christmas on the 24th, and there are a bunch of holidays in between. And in Iceland, the 12 or 13 Santas are coming to town very shortly. Guys, enjoy your holidays. We'll have more episodes before Christmas and, of course, after that. If you're in the car, driving home after work or sitting at home during the holidays, just turn on the pod, listen for 10 minutes, learn something new. Or if you're an industry expert, listen to us two boys talk about whatever, and whatever it is that you're working in, give us criticisms. We love our criticisms. A lot of people are reaching out. That's great. We're getting feedback. If we're saying something that's not right, let us know. If we're saying something that's right, let us know. We want you guys to be a part of this just as we are. We built this on the basis that we have a community called Provider Legion, which is a bunch of really great minds coming together, and it's not being shared with the world. That's what we're trying to do, to demystify these umbrella terms, these things that nobody knows really what are unless you're an expert. So have a happy holidays, and I'll see you around.